Example 3. Example 3 says find the gradient of the normal to the curve. And all that you remember is that the normal is at right angles to the tangent. Alright? So I can find dy by dx, which gives me the gradient of the curve. Now the gradient of the curve is equal to the gradient of the tangent. And the normal is at right angles to the tangent. So I have y is equal to 4x cubed minus 3x squared plus x plus 1 dy by dx. 3 comes to the front, so it's 3 times 4, which is 12. X, you decrease the power by 1 from 3 to 2, minus 2 3s are 6, decrease the power from 2 to 1, and plus if you decrease x, you're going to get 1. And if you differentiate 1, you're going to get 0. So dy by dx is the gradient of the curve. So I'm going to say when x is equal to 1, dy by dx, which is the gradient of the curve, is 12 times 1 squared minus 6 times 1 plus 1. So this is going to be 12 minus 6 plus 1. So let's say this is 12 minus 6 plus 1, and this is 7. So the gradient of the tangent which is equal to the gradient of the curve is 7. And now lastly, the gradient of normal, let's say m2, is equal to minus 1 over 7. Alright, so where is that coming from? That's coming from your knowledge of coordinate geometry, which is essentially saying that if I know the gradient of a straight line, in this case the gradient of the tangent, which is 7, to find the gradient of all lines perpendicular to the tangent, I must invert the gradient and change its sign. Alright, so the gradient of the tangent is what? 7, positive 7. The gradient of the normal, which is perpendicular to the tangent, is minus 1 over 7. 7 is the same as saying 7 over 1. So if I invert 7 over 1, I'm going to get 1 over 7. And if I change the sign from positive, it's going to become negative. Example 4. It says given that y is equal to 4x cubed minus 6 over x squared, find the gradient of the tangent to the curve at x is equal to 2. Alright, so I have y is equal to 4x cubed minus 6, sorry, x is not there. I could put it there. Alright, let's just start with it there, 6 to the minus 2. Alright, so that is just me applying what? That's just applying what a law of indices. Alright, the power is positive at the bottom, when you bring it up, it becomes negative. Now let's differentiate. Dy by dx would be equal to 12x squared, and negative times a negative is a positive, plus 12x to the minus 3. So this is a standard power differentiation. You multiply the coefficient by the power, decrease the power by 1, and then decrease the power by 1. Alright, so this is the same as saying dy by dx would be equal to 12x squared plus 12 over x cubed. All right, let's go to the next page. All right, so again, dy by dx is equal to 12x squared plus 12 over x cubed. All right, and then I'm going to say when x is equal to 2, dy by dx, which is the gradient of the curve, is equal to 12 times 2 squared plus 12 over 2 cubed. 2 squared is 4, 4 times 12 is 48, plus 12 over 8, divide both top and this is 2, and this is 3. 3 over 1 is the same as saying 1.5. 1.5 plus 48 is equal to 49.5. So the gradient of the curve is 49.5 at x is equal to 2. This is also equal to the gradient of the tangent. All right. So let's just go back a little just to see what we're asked to do. The gradient of the tangent. We're asked to find the gradient of the tangent, which we did. So if we want, we probably could make a little statement by saying that gradient of tangent m is equal to 49.5. So the gradient of the curve is equal to the gradient of the tangent. dy by dx calculates the gradient of the curve, and the gradient of the curve is equal to the gradient of the tangent. Example 5. The curve y is equal to 2x squared minus 3x plus 1. Find the equation of the tangent to the curve and the equation of the normal to the curve at x is equal to 2. Alright, so now we're being asked to find the equation of the tangent. Remember, the tangent is a straight line, so your knowledge of coordinate geometry, both the tangent and normal are what? Are a straight line. What we do know is that dy by dx, which is the gradient of the curve, is equal to the gradient of the tangent to the curve. So let's start out by finding dy by dx, because by finding dy by dx, we can determine the gradient of the tangent. And once using the gradient of the tangent and the point of contact, we can determine the equation of the tangent. Alright, so where do I want to start? Do I want to start with dy by dx, or do I want to start with, let's start with dy by dx. So y is equal to 2x squared minus 3x plus 1. Dy by dx is equal to 4x minus 3. Alright, 2 times 2 is 4, decrease the power by 1, minus 3, and differentiate 3x you get 3, differentiate 1 you get 0. Now, next I'm going to say at x is equal to 2, dy by dx would be equal to 4 times 2 minus 3. 4 times 2 is 8, 8 minus 3 is 5. So the gradient is 5. Alright, so m, the gradient of the tangent, is also equal to 5. The gradient of the curve is equal to the gradient of the tangent to the curve. Alright, I need a point. In order for you to determine the equation of a straight line, you need a gradient and you need 1 point on the line itself, 1 point on the tangent. The point of contact, that's where the tangent meet the curve. I can find that out because that point is common to both the tangent and the curve. So I'm going to say again, from when x is equal to 2, y would be equal to 2 times 2 squared minus 3 times 2 plus 1. Therefore, y would be equal to 8 minus 6 plus 1, which is equal to 3. So the point of contact is when x is 2, y is 3. The point of contact is 2 and 3. So the point of contact is common to both the what? Tangent, curve, and normal. The point of contact is common, all three of them touches it. The point of contact is where the tangent touches the curve, so it's on both the tangent and the curve. And the normal passes through the point of contact as well. Alright, so now find the equation of a tangent. Equation of tangent. Using the formula y is equal to m into x minus x naught plus y naught. M is the gradient, so m is equal to 5. X naught, y naught is 1 point on the curve. So the point of contact, sorry, is 1 point on the tangent. The point of contact is a point on the tangent. So this is my x naught and my y naught. I can put in all my values to say that y is equal to 5 into x minus x naught, which is 2, plus y naught, which is 3. This is 5x minus 10 plus 3. Therefore, y is equal to 5x minus 7 is the equation of the tangent. Y is equal to 5x minus 7 is the equation of the tangent. Now let's go for equation of normal. The formula we're using is y is equal to m into x minus x naught plus y naught. Now m2, the gradient of the what? Tangent, is equal to minus 1 over 5. So what do we have to remember? We have to remember that if we know the gradient of the tangent, to find the gradient of the normal, we invert the gradient and change its sign. Alright, and that's coming from coordinate geometry. 1 point on the normal is also the point of contact. Which is 2, 3. Alright, and this is my x naught and my y naught. So y is equal to minus 1 over 5, x minus 2 plus 3. Alright, this is very simple. We just need to work it out. Move the bracket by applying distributive law. So this is minus 1 over 5 x, and negative times a negative is a positive. 2 times 1 over 5, which is 2 over 5, plus 3. This is minus 1 over 5 x plus 2 over 5 plus 15 over 5. Alright, so there's like 3 over 1. Multiply the top by 5 and multiply the bottom by 5. Alright, so that's all that I can get a numerator of 5, denominator of 5. Alright, so this is the same as saying minus 1 over 5x plus 17 over 5. Alright, and that would be the equation of the normal. That would be the equation of the normal. Alright, so we're asked to find both the equation of the tangent and the equation of the normal. Alright, first thing I had to do was to find the gradient of the curve, which is equal to the gradient of the tangent. So now that I know the gradient of the tangent, I would also need to know one point on the tangent in order to determine the equation of the tangent. And I remember that the point from the curve, I can use the curve to determine the point of contact, which is common to both the curve, tangent, and the normal. And from that, I can find both the equation of the tangent and the equation of the normal.